to Chapter 1, Section 1. We're going to talk about safety in the workplace. Now, safety is extremely important because it doesn't matter whether it's a small project. Maybe it's a mom and pop where you have an electrician and a helper, or you have a large crew doing a multi-family building with multiple individual dwelling units. Safety is paramount, okay? Electricity is great when it stays in its intended path, follows all the circuit conductors, returns back to the source, everything works fine. When it gets out of that intended path, that's where problems can happen. Electricity out of its intended path can be extremely dangerous, and it results in fire, damage to equipment, as well as serious injury or even death. So if you're in our program, you're following along with me, I will read the information on the screen and give you commentary, as I always do, on things that are important to be aware of. Now, as it says on your screen, before getting into residential wiring or even talking about the National Electrical Code, the NEC, which is the acronym for the National Electrical Code, we need to discuss on-job safety. We need to discuss that safety is no joke and that it doesn't matter how small the project is or how large the project is. It's extremely important. Electricians working on new construction, remodels, maintenance, even repair electricians will find that electricity is just part of the everyday work environment. Electricity is all around us, just waiting for that opportunity to do the task that it's intended to do or get out of control. Now, one of the things we want to remember is safety, safety, safety. So if there's something you should remember, it's what you see here on the screen. Safety first, safety last, safety always. Clean job sites, clean work environment, clean tools, no damaged products in use. All those things add to the level of safety. We want to make sure that we get home to our family every night in this profession. Now let's talk a little bit about voltage. Now it's the current that does the damage, but it's the voltage that pushes the current. So we need to look at it. The voltage level in a home traditionally is going to have 120 volt circuits and 240 volt circuits. Again, we're talking residential applications here. Now, when you think of 120 volts nominal circuit, we're talking about one ungrounded hot conductor and its potential relation to an ungrounded or a neutral conductor, black and a white, if you will. So the difference of potential between the two is 120 volts. If you think about how that works in a transformer, and we're talking about the single winding that is used to supply power to a residence, then you've got a winding in the transformer at the secondary that is a potential between the 2 points at opposite ends of that winding is 240 volts. Of course, with 120, we tap midway. That's why we bring 3 conductors traditionally down to a residence. From that midpoint to any end of that winding, you're going to get 120 volts. Okay? You're tapping that 240 right in the middle. Hence, 120 is half of 240. Now, if you measure at each end of that winding, or conversely, if you're in the panel and you stick a voltmeter on line 1 and line 2, you're going to get 240 volts of potential because it's utilizing that entire winding of that secondary transformer. Okay, so the differences of potential are what we're looking for because that's what allows current to flow. But when you're measuring it with voltmeters, remember, line to line, 240 volts. Line to neutral or line to grounded metal parts is 120 volts. All of which can cause death, severe injury, shock, which could result in a reactionary move that could fall off ladders and all those type of things. So extremely important to remember that even with 120 volt circuits, the potential for death or injury is great. So you always want to treat those circuits with extreme caution. Make sure you're following your proper PPE. Make sure you de-energize the circuit before you do any work on it. Of course, we're going to cover that a little more here as we get into these safety aspects. I know you're jonesing to get into the actual residential wiring, but again, people get very complacent about electrical safety, and I want to make sure that all my fellow electrical brothers and sisters get home. Okay, might sound cliche, but from somebody like me who's been teaching this for over 30 years, it is so important that we think of electrical safety so that you can go do your job and then get home safely. That means an awful lot to people like me who spend their whole career trying to teach electrical and teach the safety aspects of it. Now, safety alert. Working with switches and receptacles, both are devices, luminaires or appliances with the power turned on is dangerous. In fact, I cannot think of a single reason in a residential application that you would need to work with anything with the power on. Okay? If anybody asks you to do that, you have to wonder why. Either they're lazy, simply go to the panel, turn off the breaker, verify with a voltmeter that the circuit is de-energized, do the work without any inhibitions, and then go and turn it back on, and that's the process. There's no real need to do anything hot anymore. Why would you do it? Okay. With that said, you want to make sure that you have a good voltmeter, and you want to make sure that you check that the power's off. Again, one of those procedures we always used to teach in school was check, make sure your voltmeter works properly on a known circuit, and then check the circuit that you're intended to work on or the piece of equipment to make sure that it has been properly de-energized. You need to make sure your voltmeter works perfectly fine before you rely on it, okay? And that's the same with those little tickers. Again, make sure you check them on a known source before you go and just wildly work on something thinking it's de-energized when it could be a bad voltmeter, could be a bad ticker tester. So again, safety practices are paramount here. Okay, so you want to test with a voltage tester, you want to test it on a known live source, then you test on the circuit that you're going to work on or the piece of equipment that's energized. You want to make sure that you have de-energized it, and you validate that with your voltmeter or your tester. That is so critically important, okay? Making sure that the products are operational and in good working order, very important. And every electrician should know that right off the bat. All right, so let's kind of look at this concept of circuits and where the potential is and how you can get shocked. An electrical shock is received when electrical current passes through the body. Okay, so touch potentials. Okay, I'm touching something, and this touches a live circuit, and this hand's touching a grounded metal part. Current's always trying to get back to the source, so it's going to pass through me. I'm just something that got in the way. Depending on your body's resistance, and everybody's a little different, then you know what? It might be all it takes to make for a really, really bad day. Now, you might remember from your basic electrical theory classes, whether you were in vocational school or an apprenticeship program, or learned from a seasoned electrician who was willing to teach you out in the field, and that's becoming a rarity. Thus why it's so important for courses like this to share this information. Because look, you learn that the line voltage appears across an open and a series circuit. Look at the picture on the screen in this figure. This is a circuit. Starts out at the source, goes to a device like a switch, goes through the load, and then goes back to the source. Now, of course, we're talking alternating current, so it's changing direction 60 times a second. Thus, we talk about 60 hertz. Okay. Now, but what you have to remember is, see where the voltmeter is. These are across 2 points. So the neutral conductor goes straight through the load, straight to the, let's say, load side of this switch. And then the line side is the ungrounded conductor that comes from the hot or ungrounded connection point in the panel. So there's a difference of potential across this. That switch that closes it creates the closed loop. If you come in contact across these 2 terminal points, you become the resistance in there. You're completing the circuit, okay? So you could get caught in series with 120 volt circuits, which will give you a 120 volt shock. For example, open circuit voltage between 2 terminals of a single pole switch, like you see on the screen here, on a lighting circuit is 120 volts when the switch is in the off position and the lamp are in the circuit. So I've got a lamp in the circuit, it's completing the circuit. I come in contact with these 2 terminal points, it's going to flow through me, okay? Now, as you see in figure 1.1, likewise, getting caught in a series circuit, if it was a 240 volt circuit, you also, if you're in series with it, you are going to receive a 240 volt shock, okay? So why work on something energized? The shock potential is there. Now, you might say to yourself, well, it's not going to electrocute me. It could. All it causes is for your heart to go into fibrillation. It can't pump oxygen to the brain, and you will die. Okay, that's a direct result of the shock incident. Now, secondarily, you could get shocked and you're on a ladder. You're on scaffolding. You're up on something and you fall off. So that's a reactionary aspect of it where you could break your neck, fall, get killed that way. Okay. Or you could have a reaction where you pull away from something and you get caught into some other moving part, like an adjacent fan or a pulley or something like that. Again, why work on energized parts? It's not necessary, and certainly not necessary for residential. You can argue commercial, you can argue where removal of power creates a greater hazard. That's not residential. Okay, so for all of you commercial guys, leave that in the commercial realm. Right here, we're talking residential. Service guys, maintenance folks, new construction, renovation, no need to work on it energized. No need for it. Now, if you have panels, for example, where the lines come into the panel, you'll have barriers now on the line lugs that come in, but you have a main breaker for the most part, that kills the bus. So you're working below those live parts, okay? But you still have to use precautions. You still have to be aware of what's going on, and the manufacturers are doing things to try to make you as safe as they can. Again, common sense has still got to always be prevalent when you're working with electricity. All right. Now, working on equipment with the power turned on can result, obviously, in death and serious injury, such as a direct result of the shock itself, which is electrocution or severe level of burns that you just don't survive, okay? Maybe third-degree burns over a certain percentage of the body that results in death. Or you could be injured severely from a reaction from a shock. Whereas you fall off a ladder, you jerk away because you got in contact with a hot conductor and maybe your other hand was touching a grounded part and you jerked away. And then what happened is you have some other piece of the moving equipment that's associated with the piece of equipment you're working on, or something that's nearby, and maybe it's the blades of a fan, or maybe it's a pulley or something that you get caught in. It pulls your clothes into it and you end up getting harmed that way. Now, as you see on the screen here, there is an example. And this is just one of many examples. And I will give you one of my own situations where I was involved in it. Now, for example, a workman was seriously injured while working in a live circuit that supplied a piece of equipment. He accidentally came in contact with a hot, ungrounded terminal conductor or a terminal, and the reflex action caused him to pull his hand away. But actually, when he did that, it went into a pulley. And that pulley system deeply cut into his wrist, resulting in a tremendous loss of blood. All this was unnecessary, but that was a reactionary. So it wasn't the shock. Just when he thought that that was okay, the reaction caused something else to happen. Okay? Bad day, no need for it. Okay? A simple service call could result in something serious if you don't think about it. Remember, we're there professionals. We're there to get the job done. We're there to set a good image to our client, represent our company well, get it done, get out of there safely, okay? Next thing, what if you're working on something and you're trying to work around it very cautiously, but you don't want to de-energize it because either you're lazy or you're just like, I just don't want to go to the panel. I don't want to go hunting for it. Okay, you're using a tool or you're drilling into a box and you have the metal shavings, the flyings, and they fall into the live parts, okay? And maybe they cut into a live conductor and a neutral conductor at the same time, creating a dead short, okay? Or maybe they fall into a ungrounded hot conductor and it comes in contact with a grounded surface at the same time. Then it creates an arc flash, okay? And if it's large enough and the voltage pressure is there and you have enough current that is absorbed into this arc flash, then what happens is you could have a concussionary effect on you. It blows you off of things, could knock you off ladders and stuff like that. But also, what happens is that molten metal from that arc blast can be devastating. That's what takes us to the safety alert, in my experience with a person that I knew very well. Now, a short circuit or ground fault is a lot of energy at one concentrated location where the ground fault or short circuit takes place. It can result in a devastating arc flash, subsequently also an arc blast, that can cause serious injury or even death. Now, the heat of an electrical arc has been determined to be hotter than the surface of the sun. Think about that for a second. Tiny hot balls of copper, a plasma field, can fly into your eyes, into your skin. And in my situation, it was a simple 120, 240 volt panel that had a short circuit condition that caused copper to vaporize, and the guy was working on it. It's a friend of mine, and a piece of the copper got into his eye, and it just was a perfect storm, if you will. He lost his eyesight in that one eye. That's forever, folks. Forever. So he was complacent. He'll admit he was complacent. He just started working in there. I'm an electrician. I know what I'm doing. And all of a sudden, something happened. Okay? Don't wear metal rings. Don't wear conductive jewelry. Don't wear watches that are in their metal. There's common sense here, but as we go through this program, you're going to see different things that should make you go, okay, I get it. Okay? Now, another one we'll look at is, let's start looking a little bit at disconnecting means, because that plays a very important role in safety. Now, this is figure 1-2 in your program, and it shows a disconnect switch that has been locked and tagged. So this is locked in the open position. And of course, in this scenario right here, this would be something that would be used in a lockout tagout procedure. So maybe this disconnect is a disconnect that was required for a specific piece of equipment, or maybe something was not within sight, but it required a disconnecting means. So maybe 110.25, which we'll learn about, gave us the ability to lock something in the open position. And this is what they used here. And this locked it and they tagged it, part of a lockout tagout procedure. Now, we will cover some of that in this program, but nothing takes the place of a good safety training that's put on by NFPA or something in 70E to really hammer home these safety practices that you should get used to. Now, OSHA has the same type of material that we'll cover, but remember, OSHA's probably not going to be involved in smaller residential applications unless you're doing a large commercial project that has individual dwelling units that would fall under the scope of a commercial project. Then OSHA gets more involved, and usually after there's an accident. But there are procedures that your company has to follow with safety meetings and things like that that you need to keep records of. Now, you're a small electrical contractor or residential guy or gal, you might not have those same requirements on you, but you still should have a good understanding of safety and procedures and how to put things in a safe working condition, most certainly. Now, the other example we're going to look at this is figure 1-3. This shows circuit breaker panel board that has a lock-off accessory that's actually been installed itself. So we're going to look at that because that is also a safety device as well. So as you can see here, these are placed. These are lock-off accessories that can be added to a panel cover, and it's basically fits right over the device, which in this case is a circuit breaker. And this allows for a lock to be applied. So you can lock it in the open position. Okay, so these things are fundamentally going to be covered in our course because we're going to talk about different pieces of, even in residential, different appliances that are going to require to have a disconnect within sight, with a caveat that you could have a disconnect that's not within sight if it's lockable in the open position under 110.25. So we're going to cover all that, but it's important that you understand what these devices are and how they can play a role in electrical safety, most certainly. Now, every company, whether you're a small mom and pop or you're a large company, needs to understand lockout tagout. Now, again, whether you're a residential contractor and you're thinking, I have no need for this lockout tagout. It's important for you to understand it because maybe you're going to grow into a contractor that does larger projects, or maybe you're an electrician who's working in residential on a large commercial project. And there's so many people going in and out of these projects, and so many people that are working on things that somebody can inadvertently turn the power on when you followed all the procedures to be safe, you turned everything off, but then somebody comes and accidentally turns it on. So you have to understand lockout tagout procedures, whether or not you're a mom and pop or you're a huge contractor. You want to make sure that everybody understands it and how to perform it. Now, this is a bit of a summary. You really need to look at NFPA 70E, for example, and has a very extensive lockout tagout procedure that you can follow, but we will cover the highlights here. Number one, if you're dealing in a condition where you're going to be working on equipment, you want to make sure that you're verifying that you have the proper PPE, that's personal protective equipment, whether it's the glasses, hearing protection, fire retardant gear, clothing, boots, and all those type of things. And you need to understand when it's required and that you need to put it on. A lot of people get PPE and they never use it, okay? Even the simplest is working in an electrical panel in an electrical residence. of the importance of gloves, eye protection. Like I said, in my example, the gentleman was simply working in a 122/40 volt panel, and because of a short circuit condition, he is now blind in one eye. Again, can happen in the blink of an eye. No pun intended, but it can happen that quickly. So verify the ratings for PPE, know when to use it. If you have to remove the covers on equipment, if necessary, be very careful and cautious in removing that equipment, exposing those live parts in the process of de-energizing it or verifying that the system has been de-energized. Again, opening the circuit breaker or fuse switch ahead of the equipment that you're going to be working on. That's where your lockout, tag out is going to take place upstream to make sure that you lock it out, tag it out, de-energize the circuit before I work on something. Okay. Next, testing the operation of a voltmeter on a known live source. Again, make sure your equipment works properly. Test it. Verify it's working on something you know is working. And then you use that in testing that you've de-energized successfully the equipment that you're going to be working on. Sounds like common sense, but how often do you do that? I can tell you right now, if my guys, and I was a contractor, if my guys went out to do a ceiling fan swap or put a new ceiling fan in, they better cut the power off when they do it. They better not be working on anything. They better not be taking that ceiling fan down that's there while it's energized, okay? Or putting the new one up while energized. Better not happen. If they get shocked and fall off a ladder as a subsequent reaction to being shocked, then my insurance would not cover them, because I needed to make sure that my employees knew the precautions that they had to take when working with electricity, and we did safety training, okay? They're working on something that they did not need to work on live, okay? Everybody's different, everybody's insurance is different, but again, don't need to have that happen. Okay, so test it, and then when you work on the equipment, you want to make sure that the voltmeter works, that you're testing it on the equipment, and we're looking for the absence of voltage. Okay, now you test that voltmeter again to make sure it's still working, so it didn't stop working. So test it, check for absence of voltage, and real quickly test it again on whatever the known circuit was that works, just to make sure it's still working. And now you're safely in a condition where you can go working on that system without any fear of getting shocked. Okay, makes sense? All right, now when it comes to the upstream breaker, upstream switch, or whatever, in order to put the entire circuit in a safe working condition, that's where you're going to use the processes of lockout, tag out. You're going to put a lock on it, padlock. That's your padlock. You're responsible for your safety. Don't rely on somebody else. You are responsible for it. So it's my lock, my key, and my warning tag. Now, some people ask me, how does this relate to residential? Well, when I went to people's houses and I was working, let's say for the husband, the wife was still in the house. She might be familiar with turning circuit breakers on or not, or he might be if I'm working doing something. Not everybody knows when I'm there and what I'm there to do. So when I turn something off, if they don't have a lockout in it, again, it's just residential, but me, I was famous for actually having a label that I would apply to the front. It was a magnet that I would apply to the front of the panel, or I would just tape a sign up that says, do not enter this enclosure, electrical work in progress, something to that. And it's as simple as putting it there when I go to turn the breaker off and verify, just to put it off, turn it off, and actually put the label up there. Again, that's to let people know somebody's doing some work here. So even if you just do that in a residential, or you get your guys and gals to do that, again, it forces them to do this and follow the procedure, then they don't work on stuff that's live. It's unnecessary today. It is. Now, only after following each step in this procedure is the equipment considered safe to work on by OSHA or in just plain common sense. You don't have to worry about coming in contact with something as you're doing it. Okay, you don't have to worry about working in a box on a ladder and getting shocked and falling off, or like, oh, let me touch this. You feel confident. It's all off. You can get the work done quicker, more efficiently, and you can be neater in how you're getting things in the box because you're not worried about shorting something out. Okay. Now, equipment that is cord and plug connected can be worked on safely after removing the plug from a receptacle. Obviously, if it's a piece of equipment, you're working on it, and you pull the attachment plug out of a receptacle, obviously there's no power going to it. You can work on it. But I will say that this is not about the cord and plug, but as an electrician, you might turn off a circuit to work on something that has capacitors in it. Again, Be very careful because they can store a charge. If you know what capacitors are, if you've been through our Electricity 101 course, it stores a certain amount of energy that can be discharged. And that can be a resulting in a shock. And it might not, obviously not going to electrocute you, but it can stun you and cause you to fall off a ladder or something, or have a reactionary response that could cause you to move into something else that could cause a problem. So just think about those things, common sense. Example, a capacitor might be working on an air conditioning unit outside if you're an electrician working on it and you cut the power off, but you didn't discharge the capacitors. It might be, you could get a shock. So just think about those things, okay? Now, dirt, debris, and moisture, obviously, can also set the stage for equipment failure. Using equipment that are placed in locations that aren't rated for that environment. Using a NEMA 1 in a location where you really needed a NEMA 3R for rain and moisture. All those type of things. And when you're going to go into that equipment, you should start having red flags come up. When you see something, you go, whoa, wait a minute. This isn't rated for this environment. I'm getting ready to go in this thing. Your cautious level should start to rise. Get those protective gear on. You might say, well, it looks fine. Put your gloves on to open that up. You don't know if it's energized. You don't know what the dirt, debris, you don't know what the moisture could have done to this. How about equipment that's in a building and you're getting ready to work on it, but it's got knockouts missing? It looks like shoddy electrical work, but you're getting ready to stick your hands on it. You need to always raise that level of cautious and say, wait a minute, I am going to get home tonight to my family. I got more things that I want to do. This ain't a one-trick pony for me. All those things need to be thought about when you're working on equipment. Now, it is something that's also important to understand when people talk about shock, because we talk about voltage, 120 volt, 240 volt, voltage potential. When you have differences of potential between 2 points, it gives the ability for current to be exchanged from these 2 points. Now, the current is the harmful component in the electrical circuit. Voltage just pushes that current through the circuit. Now, in this example, you and another person represent the resistor in a circuit. The circuit voltage pushes current through the person. If you're not careful, you might become part of that circuit, okay? Now, if I'm working on something and I've got my hands in there and I'm working on it live, or maybe I'm working on a ladder and I'm working in a circuit, and I have people tell me this all the time. Paul, you don't use metal ladders to hang a lighting luminaire or something like that. And I always tell people why. Because the anticipation is that the people, well, not anticipation, people will assume, I guess, that you're an electrician, that you're working on it live. I'm not working on it live. I'm de-energizing it. Why can't I use a metal ladder? That's why you follow these procedures. Now, you get complacent, you get really rushed, you go in with a metal ladder like a Little Giant or a Werner ladder, which are perfectly fine. You start working on it, you didn't de-energize it, and now what happens? Well, what happens is you could get a shock. You're touching a ladder or something, and maybe it's on concrete and it's not insulated between it. Anyway, you get a shock and you fall off this ladder. Okay? So many things to think about. If you get in that path, if your body becomes part of that circuit, as we saw before, that current will travel through you. And it only takes about 1/10 of an amp to kill you. Yeah. We electrocute people today. I don't know how much we do that anymore, but we put literally thousands of volts, 35,000, 40,000, 50,000 of volts through somebody to kill them supposedly humanely. We can do the same thing with a 15 amp branch circuit. It only takes 1/10 of an amp to kill you if you're set up right. If you're bonded right, if you're in the circuit right, it can happen. It causes your heart to go into ventricular fibrillation. It just starts fluttering, and it doesn't push any oxygen to the brain. And it doesn't take very long, so we use a defibrillator to try to shock it back into rhythm so that it can effectively pump blood to the brain. Oxygen, okay? That's what usually will get you there. You starve your brain of the oxygen, you go brain dead, and ultimately, if your brain's not working, none of the other organs are going to work, and that ends up being the end. So, again, be very careful. Take this stuff seriously. Now, the higher the voltage, the greater the current. So we have 240 volts, 480 volts, 600 volt applications. Not only can this have a lot more pressure, which can draw more current, but also it has the potential for greater impacts from things like burns from an arc incident. Okay, and so again, we saw that a simple 120 to 40 volt can cause devastating effect on somebody. But as you step up the voltages and it increases the greater propensity for current, then you start getting into other aspects of where you can have a greater blast, more intensity of a blast, resulting in severe burns, okay? And also, it could cause internal damage that you might not see on the surface, but later you start having tissue failure, organ failure, nerve damage, all these type of things that can be obviously devastating to you as an electrician and your family. So definitely want to be as safe as you can be. That's what we're here for. All right, let's talk a little bit about the law. Okay, so we're in Unit 1 or Chapter 1 and Section 1, and we're talking A, it is the law. Not only is it a good idea to use proper safety measures as you work on and around electrical equipment, it's required by law. And what do we mean by that? Well, when the National Electrical Code is adopted by your jurisdiction, by your state, it has certain procedures in there, certain things that you're going to be doing electrical work. It's going to assume that you have the training, the skills, the knowledge in order to obtain that licensure. But also, when you start doing larger projects, then you get things like OSHA involved. And all of those type of things can make for a very bad day for somebody that doesn't follow those minimum safety standard practice. Now, electricians and electrical contractors, they need to be fully aware of all the regulations in their state, all the way down to local jurisdictions, which sometimes can actually amend or modify state requirements, okay? Now, practicing safety is a habit. It needs to be habitual. You need to think safety always. Safety first, safety last, safety always. That needs to be your mentality. Get in, get the job done, but always think about safety, okay? Always think about safety. Now, it's like putting a seatbelt on your car, okay? You need to do it. It's a law. You've got to do it. Some people don't, but you really need to make it habitual, that you think about safety every time you get ready to go into it. When I go, even today, if I go out and do an electrical project, I am not working on it live. I have not yet found a reason to. If you think you have a reason, you don't. We're not talking commercial. We're not talking nursing homes. We're talking residential here. There is no reason, okay? No reason at all for you to have to do this. All right, now, the NEC is full of requirements that are safety related. Remember, the National Electrical Code is, and the acronym for that is NEC, is a minimum safety standard. Now, people hate that term, minimum safety standards, but that's what it is. If you meet the NEC, that's the most minimally is safe of a structure you're going to have. Can you go above the minimums? Absolutely, but you have to follow the minimums. It's adopted in your state. Now, there are random states that don't, but at the end of the day, if somebody gets hurt, they're going to be looking at what standard you used as a safety standard. And we utilize the National Electrical Code for this. Now, for example, 430.102b requires that disconnecting means be located in sight from a motor location and the driven machinery location. This section is also has an insight and a lock off or lockout requirement. And we'll discuss those when we get to chapter 19 and 23 of this series. But there are occasions, for example, with a within sight rule, as you see over in the Article 100 for definitions, is it has to be within 50 feet and visible to be within sight. So anywhere in the code that says something has to be within sight, a disconnect has to be within sight, it's got to be within 50 feet of the equipment and within sight. If it was 48 feet from the equipment, but it was around the corner and it wasn't within sight, then it doesn't meet the within sight rule. Just because it's within 50 feet, it's still not within sight, okay? Now, there is an allowances many times in the code, and you'll see that we'll get to that when you have an appliance that says, look, this appliance needs a disconnecting means. However, we will let you have that disconnect means either within sight, or if it's not within sight, then you have to have a lockout procedure. And we'll tell you that you're going to be following the rules in 110.25. You're going to lock the circuit in an open position, and that can be utilized in order to safely work on that piece of equipment. So we do have some rules that we have to follow. They're all very much safety driven. Now, when somebody works on something, they have to be a qualified person. Now, I'm going to tell you right now, if you're an electrician but somebody asks you to do some PV work, photovoltaic work, and you have never done PV before in your life, even though your license allows you to do it, but you've never done it, you're not qualified. You need to take some training, take a course. You need to learn the skills. You need to gain the knowledge before you do it, because you are not considered a qualified person. So look what we've got here on the screen. Now, this grayed out area that you see means it's extracted text from the National Electrical Code. It says the NEC in Article 100 defines a qualified person. And again, this is very similar to what OSHA says as well. It says one who has skills and knowledge related to construction and operation of an electrical equipment and installations, and has received safety training to recognize and avoid the hazards that are involved. If you don't know anything about PV systems, then you'd have no idea what hazards are involved. So you have to gain that knowledge. You have to gain that training, okay? Merely telling someone or being told to be careful does not meet the proper definition of training, and it does not make you a qualified person. So if you're the owner or you're the foreman and you're telling somebody to do a task that they've never done, they've not trained in it, you haven't provided them with that training, then you're asking them to do something that they are not qualified to do. And that's not what is expected of somebody to do. We need to train them. They need to be aware of what hazards are involved, and they need to be very knowledgeable in what they're doing. So again, an individual qualified in one skill might very well be unqualified in other skills, okay? So keep that in mind and provide that training to your staff on anything that you ask them to do. Make sure that they're familiar with doing it. Now, according to NFPA 70E, which is Electrical Safety in the Workplace, I don't know how many residential folks have this document. It's a thin document. It's an important document. And again, as an owner, I always hammered home safety. Not only do I want my employees to get home safe to their families, I don't want any lawsuits. I don't want to have to file any claims that makes my insurance go up. It's all par for doing business. I wanted to keep everybody safe. I wanted to not be known as the careless, reckless contractor. It's an inexpensive document, and it has a lot of good charts that make things easy to understand. So whether you feel they apply to residential or not, it is an extremely important document to be familiar with, and it's inexpensive, and it's a great publication by NFPA. Now, here's what NFPA 70 actually says. It says circuits and conductors are not considered to be in an electrically safe condition until all sources of energy are removed. It's exactly what it says. De-energize it. It says the disconnecting means is under a lockout and tagout, and the absence of voltage is verified by an approved voltage tester. All of this stuff we just kind of talked about, making sure your voltage tester works, making sure you have a procedure in place in order to do that. Now, since residential probably doesn't have a whole lot of lockout tagouts until you start getting to a commercial setting, whereas you have probably a switchgear room or something down in a basement, but you have all these individual dwelling units, then it becomes even a higher level, and OSHA obviously gets involved in that when somebody gets hurt. But you're a 1 and 2 family guy, you're just doing residential stuff, you still want to follow those same principles. And that's why I said I came up with a little sign that I would put on the panels when my guys are working anything. Obviously, this is not going to be for the rough ends and things like that. This is for the finals. This is when you're going back, putting switches, receptacles in, if the power's on, all those type of things. If you're doing service calls, repair work, all these safety precautions, and it really can look good for your business as well, because you're conveying it to your customer. See how safe I am? I'm a professional. This is how I do it. Take pride in what you do. If you're saying this is all too much for you to be that safe, maybe you should think about changing professions, because we want you to be safe, right? Now, the U.S. Department of Labor, the Occupational Safety and Health Administration, that is OSHA, it has regulations in standards 29 CFR, and it is the law. Now, it applies mainly to commercial applications, industrial applications, less to the single-family dwelling aspect of it. However, there are very important safety procedures that are in OSHA that most contractors and knowledgeable electricians should be very aware of, because they are very relevant. Okay, and it is a lot of this information is where we get a lot of guidance in the other documents that we use in our trade. Okay, so this entire standard relates to the safety in the workplace for general industry. Okay? Specifically, there is a part in there that deals with electrical systems and electrical safety, and that is Part 1910, Subpart S, and that involves electrical safety requirements. The letters CFR stand for Code of Federal Regulation, in case you ever wondered what that means. Now, key topics in the standard are ARC, or electrical utilization equipment or systems, wiring design and protection. It's going to cover wiring methods. It's going to cover components and equipment for general use, specific purpose equipment and installations, hazardous classified locations. Again, we covered that in the NEC. OSHA's covering it as well. Special systems, training, selection and use of proper work practices, use of equipment, safeguards for personnel protection, and definitions, many of them which are found in the National Electrical Code as well. It's also going to talk about when OSHA, when you're following the OSHA procedures, it's going to talk about certain types of reporting and keeping records and what happens with near misses and incidents that take place. Again, we're talking residential, but remember, residential doesn't mean just 1 and 2 family. Residential means individual dwelling units that could be in a commercial setting. So all these things are very important to be aware of, and we want to make sure that you're well-rounded all around the horn. Okay, so let's kind of look at some direct quotes that actually come from OSHA, so we can see how they're absorbed into other documents like the NEC. So you have a direct quote from, remember, we're talking about subpart 1910.333A1 states, quote, live parts to which an employee may be exposed shall be de-energized before the employee works on or near them, unless the employer can demonstrate that de-energizing introduces additional or increased hazards or is infeasible due to equipment design or operational limitations. All right, let's look at that part first. We have what's called a live work permit in our electrical industry. And so if my employer asks me to work on something live, then they better be well versed in how to demonstrate why it's necessary. Otherwise, it needs to be de-energized. Now, if I'm working on a nursing home and I have a bunch of people on life support and I need to work on something, then I might have to work on it live because what? By removing that or de-energizing it can raise or increase the risk of hazard to those that need those systems to stay up. So that might be an example of that. In a residential, I can't think of any reason for that. In a multifamily building that would fall under commercial with individual dwelling units, that residential aspect, I cannot think of any reason for that. Okay, at all. Just because something is inconvenient doesn't give it a demonstrated need to do something live. Okay, so if you're asked to do that from your employer to work on something live, then make sure that they sign a live work permit that requires to put all that information on it so that they're responsible for telling you to do something that you probably don't want to do. But they also require that you understand the procedures to be safe. Okay. That is on them to provide that for you. Now, we'll keep on reading it because it says live parts that operate at less than 50 volts to ground need not be de-energized if there will be no increased exposure to electrical burns or the exposure due to electric arcs. Okay, so you'd have to do an evaluation of the condition if you're dealing with something that's less than 50 volts to ground. Then you might be able to work on that without having to worry about it. One example of this would be, for example, a doorbell circuit, things like that. All right. Now, OSHA 1910.333C2 states, and this is the qualified statement, it says, only qualified persons may work on electric circuit parts or equipment that have not been de-energized under the procedures in paragraph B of this section. Such persons shall be capable of working safely on energized circuits and shall be familiar with the proper use of special precautionary techniques, personal protective equipment, insulating and shielding material, and insulated tools. So if you're going to have a situation where they have justified the work on something energized, okay, then you have to make sure that they understand the techniques to do it. They have the proper PPE necessary. They have the equipment, everything insulated. Anything that would be within reach would be insulated out, proper tools. You need to make sure that they have that. Now, if you're asking for somebody to do something live or you're the electrician that's being asked, you have to step back real quick and say, wait a minute. Have I been trained on this? Do I know the procedures, first on, last off? Do I understand the what personal protective equipment I need. Heck, if they even done a 70E training with me, all those things come up, then you want to stop. And you say, no, I don't feel comfortable with this. I really don't, okay? So again, that's probably going to come into play more for the commercial and commercial residential where you have individual dwelling units, but because it is 3 or more, that it's probably going to kick into more of a commercial environment. And again, these are all important safety procedures that we need to be aware of. Now, OSHA 1910-399 defines a qualified person. Now, this is very similar to what's in the NEC. It says, one who has received training in and has demonstrated skill and knowledge in the construction and operation of electrical equipment, which you probably do. You probably have that training, but do you have training on every aspect? Are you being asked to do things that you don't have the training on? Well, get the training, okay? Because it then goes on to say, and installation and the hazards that are involved. Very similar to what it says in the NEC, okay? But we need that training. You're getting that here. This could count as training. You're on the job training, and any specialized thing that you're doing, get that special training. PV systems, wind generation, fuel cell, all these type of renewable energy aspects of it. Make sure you get the training if you're going to work on them, because you might be qualified for one thing, but not in something else. Just because you hold that license doesn't make you qualified at everything. Now, let's also go on and see what it says here. For the most part, turning the power off and then locking and tagging a disconnect means is the safest practice, okay? Accidents can always happen even after you put something in a safe condition. So safeness is relative. However, if I'm working on a circuit and I'm working on a piece of equipment and I go upstream and I lock it off and I tag it properly, then the probability of something shocking me or me getting electrocuted is slim. That's my lock. That's my tag. Now, could somebody come and knock it off with a hammer? That's always a possibility. So that's why you always want to be guarded in what you do. But for the most part, in the professional environment that we work in, that's not going to happen. Okay. So again, the quote that comes straight out of the regulation is this, as you see it on the screen. It says, a lock and a tag shall be placed on each disconnecting mean used to de-energize circuits and equipment on which work is to be performed. The lock shall be attached so as to prevent persons from operating the disconnecting means unless they resort to undue force or the use of tools. So you have a disconnect. It's usually built. You need to have one if it needs to meet the rules of 110.25 and you're utilizing that for the lockout tag out, then you have to make sure that it can receive the lock and it does lock it in the open position. And that is about the safest practice that you can get to work on a circuit, okay? And part 1926 of OSHA regulation, that's also within standard 29 CFR, deals with safety and health regulations for construction. So think of that as an overarching umbrella, whereas we're focused recently here on 1910. Well, 1926 is like an overarching document. And again, here you'll find rules for anyone that is working in the construction industry, not just the electrical. This is for everyone. So a few of the topics that are found in there are medical services that need to be provided, first aid on the job site, safety training and education, record and reporting of injuries. That's huge when it comes to OSHA. Housekeeping, personal protective equipment, means of egress, head protection, hearing protection, eye protection, face protection where necessary, ladders, scaffolding, rigging, hands, and power tool types of procedures that you'd have to follow. Electrical requirements, again, in that 1926 is going to pretty much mirror 1910 subpart S, but you also have fall protection and required signage and tagging in the verbiage associated with that. So as you can see, there's a whole lot to learn. We're always focused on the electrical parts, which is 1910 subpart S, but there is a bigger picture here that a lot of times project managers, construction site foremans, all of those, they have to be aware of all that. And us electricians, we just think of the piece that we have to be aware of, right? A lot of stuff there is involved in the process. All right, well, folks, that's the end of Chapter 1, Part 1. or section 1. We are now going to move into part 2 here of unit 1, and that is dealing with personal protective equipment. So get buckled up. We're going to talk about PPE in the next episode. So stay safe, and we'll catch you in the next video.